Okay, here we go. We are doing 4.1, radians and degrees. And we're going to start our lesson by talking about some important terminology that we'll be using throughout our trig unit. So when we're looking at an angle that is on the coordinate plane, we're doing that for a reason. We're going to be working with the unit circle, and so the angles that we're looking at in trig will be included on a coordinate plane, encased inside a unit circle. And so when we look at angles this way, of course there's going to be a vertex, right? It's going to be that point. And then our initial side is always going to be this side. It doesn't matter what angle you're looking at in the unit circle. The initial side's always going to be the side that lies on the positive side of the x-axis. So it makes sense when you look at your angle's final destination, the second side, we would call that a terminal side. So however much your angle opens up, whatever side you end up writing down or sketching besides the initial side, that's called your terminal side. And some more terminology when we talk about positive angles, not angels. When we talk about positive angles, we're talking about an angle that has a initial side here and whose terminal side is found by rotating counterclockwise. And so it goes to, well, it makes sense that a negative angle would be the opposite, right? The negative angle would have its initial side, of course, here where all angles do, but the terminal side would be found by doing a clockwise rotation. So go this way to find this. And then we talk about coterminal angles. We're talking about two angles that have the same initial side and the same terminal side. So when you look at this picture right here, both 45 degrees, so here's 45 degrees, and if we talk about 405 degrees, right? If we started this initial side and went all the way around 360 plus another 45, that would be 405 degrees. Well, both 45 degrees and 405 degrees would be coterminal because they look the same. They have the same initial side, same terminal side. And same thing with the negative 350 degree angle. That would also be a coterminal angle. And we're going to go ahead and talk about how to find coterminal angles in just a few minutes. So our first example that we did in class, it says determine the quadrant in which each angle lies. So we want to get really good at sketching these angles. So we put up our coordinate XY axes and we think about, well, if we go all the way, we know our initial side's here, and if we rotate all the way around to the other side of the x-axis, we're going to be at 180, right? So we're going to want to back it up. So we'll back it up about 10 degrees. That's a little more than 10 degrees, but we're not going to be perfect in our sketching. So let me just redo that. Still, once again, that's going to be a little bit short of 170, but close enough. And then when we look at, do we need that little arrow part that shows which direction? No, we don't have to, but I'm just showing you which way I went. So when we're looking at negative 330, I know that my initial side, of course, is here. And if I'm going in a negative direction, I'm going to go this way. Well, if I go all the way around, that's 360, right? So I'm going to have to back it up 30. So right there would be, it looks like 45, doesn't it? Let's try again. Once again, I'm not asking you to have perfection, but I need to get a little closer. So we know that we're going all the way around negative 360. We're going to back it up 30, so that's going to be closer to that. There, that looks better. So that is, and if you wanted to show your direction that you went, you could go this way. Okay. So we're going to come back and do C and D later. I know C and D are on your notes, but we're going to come back. We did marker boards in class, but we practiced. If you want to, you can do that. Okay, so example 2, determine two coterminal angles in degree measures, one positive and one negative for these angles. So we talked in class about, obviously we just did 170, right? We had our initial side, we went all the way around almost to 180, but we stopped. Okay, so we want to find two angles that look just like this when we draw them, but have different measurement. So what we're going to do is the first thing we can do is start at the initial side, go all the way around 360 degrees, and then do another 170. So we're basically saying 360 plus, 360 plus 170. And what's that going to give me? That's going to give me a 0 and a 3, carry the 1, 530. So 530 degrees will actually look just like that red angle that we see. Same initial side, same terminal side. It's just that to get there, it had to go around one time fully before 170. Another way to find a coterminal angle that's negative, because we want one positive and one negative, is we could do it using the graph and doing it visually. I could say, well, if I went in a negative direction, I'd go this way, negative 180, and then another 10, right? So I went a negative 180 plus another 10, that would be negative 190 degrees. Well, if you didn't have your sketch or you wanted to do it a little quicker, another way to do it is to take 170 and subtract 360. I don't know if this makes sense. What we're really talking about is go all the way. Let's see, I'm running out of colors, so I'm going to have to go back to black. Okay, let's say we go all the way to 170. There's 170. And then we're going to subtract 360. Well, there we go. We end up with the same terminal side. So 170 minus 360 is going to give me my negative 190 degrees. So I wanted to show you a visual way as well as the shortcut. And the shortcut is just take your angle, add 360 to it to get a positive coterminal angle, and then to get your negative one, subtract 360. Sometimes we find if our angle is pretty big, we're going to have to subtract 360 twice to get our negative terminal angle. So let's go ahead and look at negative 330, and we know that to find one coterminal angle, I'm going to be at 30 degrees. I am tongue-tied today. And then to find the other one, we're going to go ahead and subtract 360 degrees, right? And that gives me what? 690. Okay, so even stuff like this, you're going to be expected to know when you take our unit test, right? These are building blocks that if you skip over because you're like, oh, that's so easy, it's going to make the more difficult problems more difficult. All right, so then we did some marker boards in class and we determined two coterminal angles, and so hopefully you were there for that. If you weren't, that's okay. You could do those and ask me questions if you'd like to come in during lab. All right, so radian, we talked about what exactly a radian is, and a radian has the same measurement as the circle's radius. So in this circle, though it looks like on my smartboard, it looks like an oblong circle, but it's really a circle. If we took the radius and scooched it up here, we would see that this is 1 radian. The intercepted arc is 1 radian, and the angle theta is also 1 radian. And we talked about this in class. We answered what is the unit circle, and we remembered that it's a circle whose radius is equal to 1. That's why it's called the unit circle. And so then our next question, what's the measurement of 1 radian in the unit circle? Well, the measurement would be 1, right? Because 1 radian is equal to whatever the radius is of your circle. So that answer would be 1. And then it says how many radians are in the unit circle. So it's basically asking me how many of these could I draw? You know, 1, 2, 3, etc., etc. We could kind of guess that we could, if we kept doing this, 1, 2, 3, 4, 5, 6, and a little bit. Okay, if we wanted to do that way, we could get a close approximation, or not close, a far approximation, if there is such a thing. All right, but we've got a better tool to use, and that's our circumference. So if we knew the circumference of our unit circle, which circumference is what, 2 pi r. So the circumference of our unit circle is just 2 pi, right, because r is 1, and 2 pi is about 6.28, it would make sense that we would have a little over 6 radians in a circle. But especially it's going to make sense that we would have 2 pi radians in a circle. All right, we'll come back to that last question down there. Do you have to understand totally where radians come from? It'd be nice for your brain to understand that, but you can actually keep doing trig without getting it. Maybe one day it'll just pop into your head. So the reason why we started with radians is why do we go ahead and switch back and forth between degrees and radians? Radians we're going to use more than ever than degrees when we do trig. We'll use degrees when we do word problems, but the rest of the problems we'll use radians. And so we need to know how to switch back and forth if we're given one and asked to find the other. And so it makes sense that if the circumference is all the way around 2 pi, then 2 pi radians would be the same as 360 degrees. And same thing, that 180 degrees would match up with pi radians. And so to switch from degrees to radians, we're going to be multiplying by pi over 180. And we'll do that in just a minute. I'll show you. And then to switch over from radians to degrees, we're going to be multiplying by this. Now, so far in this lesson, nothing is new. I believe that you've seen all these things. This will be the third time. I believe you've seen them in geometry and in Algebra 2 trig, but hopefully this is jogging your memory and you're like, yes, I remember. So let's practice. Wonder if they give us 120 degrees. Well, and you're wondering, which formula do I use? It's not really even a formula, but which little conversion piece do I use? Well, I see degrees and I want radians. So if I want radians, I'm going to put my pi up here. That's how I remember to put the pi on the top. The next, example 4, see how we have the pi, we'll want to put the pi in the bottom to get rid of the pi. And so we'll go ahead and simplify. My zeros cancel out. 6 goes into 12 2 times. 6 goes into 18 3 times. So we have 2 pi over 3. That means the measurement of 120 degrees is the same measurement as 2 pi over 3 radians, or 2/3 pi radians. Okay, so when we're looking at example 4 and we want to convert 7 pi to degrees, we know we want to get rid of the pi, so it goes on the bottom. We're going to get rid of the pi, and I'm going to have to grab my calculator. What is 180 times 7? Okay, 1260. Okay. Okay, we then had fun with marker boards, converting things. If you wanted to take the time to do that, you could. So now we're going to go back to example 1 on the front page, and we're going to go ahead and sketch and determine the quadrant in which each of these angles lie. So let's look at 3 pi over 4, and when I think about it, I think, well, let's look at this unit circle first of all that we have. And let's look at the degrees that we understand so far. If my initial side was this and my terminal side was this, well, it's 0 degrees, right? If I'm all the way up to, if I go all the way around, halfway around, I know that's pi, because I know all the way around is 2 pi. So already we're seeing that angles can have a lot of different names depending how many times we went around the unit circle. And so if that's pi, then I know this is pi over 2. If the circle's cut up into 4 equal parts, pi over 2 pi, this would be what, 3 pi over 2, and then that would be 2 pi. So just looking at this, if I'm looking at 3/4 pi, because that's another way we could write 3 pi over 4, it's saying I'm almost all the way to pi. So my initial side, of course, is here. I'm almost all the way to pi, but I'm actually 3/4 of the way. So if I'm 3/4 of the way, I'll be right there. It's close enough. All right, which quadrant am I in? I am in the second quadrant. All right, when we look at 2 pi over 5, let's make our own little xy coordinate plane. So 2 pi over 5, well, if I rewrote that as 2/5 pi, I'm thinking, where would 2/5 pi go? Well, if this is 0 and this is pi over 2, I have to first ask myself, is 2/5 pi larger or smaller than pi over 2? Well, if you don't know, you could compare them, right? You could say pi over 2 and 2 pi over 5, let's see, we'd have to make them have the same common denominator, so this would be rewritten as, what, 5 pi over 10, and this would be rewritten as 4 pi over 10. So you could see this way that pi over 2 is larger. Another way to do it is to say, well, 2 is smaller than half of 5. So 2/5 pi is going to be less than a half pi. So just using that knowledge, we're going to put our initial side here. And 2 pi over 5 will be a little shy, right, of pi over 2. So that angle is in the first quadrant. So we've got, with our quadrants, we have first, second, third, and fourth. I know it's coming back to you. A little practice, though, helps a lot. So example 2 says determine 2 coterminal angles in degree measure, one positive and one negative for these angles. And we are back to, we already did A and B, so we're looking at C and D. And so if I look at 3 pi over 4, remember how before I used to add 360 and subtract 360? Well, what's the same as 360? 2 pi, that's right, 2 pi. So the only problem with radians sometimes is that I'm going to have to find common denominators because I can't add these two things without finding that common denominator. So I'm going to give 2 pi a denominator of 1. I'm going to rewrite them with the same denominator, so 3 pi over 4 stays the same. And then 2 pi becomes what? 8 pi over 4, right? I multiply the bottom by 4 and the numerator by 4 to get 8 pi over 4. So when I add them up, I get 11 pi over 4. So that's one of the coterminal angles to 3 pi over 4. And I have to do the other one. So if I take 3 pi over 4 and I subtract 2 pi, once again, I'm going to change the denominator of 2 pi. Oops, and I wrote a plus, but I am subtracting. Okay, so we're going to subtract. And we'll end up with negative 5 pi over 4. So we got our positive coterminal angle and our negative coterminal angle. I know you may be wondering, why are we doing this? When we get into the more difficult parts of trig, using coterminal angles and reference angles is going to be really important. So we want to be able to do that with like our eyes closed. All right, well, maybe peeking a little bit. All right, so let's look at 2 pi over 5. We're going to do the same thing. We're going to take 2 pi over 5, and we're going to add 2 pi. But of course, we're going to rewrite 2 pi as 5. Oops, no. How about 10 pi over 5? Right? Multiply the denominator by 5, multiply the numerator by 5, and we get 12 pi. Doesn't really look like a 12, does it? Kind of looks like an R. All right, we get 12 pi over 5. So that's our positive coterminal angle. And then if we go ahead and take 2 pi over 5 and subtract 2 pi, we're going to rewrite that. Of course, I don't need to do this twice. We already did. We know that's 10 pi over 5. So that gives me a negative 8 pi over 5. So there's my negative coterminal angle. Okay, sketch and find the coterminal angle. So more practice with radians, which is good. So when I think about 13 pi over 6, I'm like, 13 pi over 6. That sounds like I'm dealing with 2 pi plus a pi over 6, don't you think? Right? Because 12 pi, 13 pi over 6, we can rewrite as 12 pi over 6 plus pi over 6. So sometimes before we even pick up our pencil to sketch an angle, we really need to pick up our pencil and figure out what we're looking at. So 13 pi over 6, we need to simplify it in a way that helps us to sketch it. Our sketch, of course, our angle is going to have initial side here, as always. And then we are going to, let's see, we're going around 2 times. Here we go. Or no, we're not going around 2 times. We're just going around once. 2 pi is here. And then we're going around an additional pi over 6. And so just as a reminder, pi over 6 is what? 30 degrees. So we're going to go up about 30 degrees. There's the angle. And so we're in the first quadrant. And then it asks us to find the coterminal angle. So we're going to take 13 pi over 6. We can add 2 pi, but we already know we're going to write that as 12 pi over 6. So we need to get good at seeing 12 pi over 6 and knowing that's 2 pi, or seeing 2 pi and be able to write it as 12 pi over 6. So that gives me 25 pi over 6. No need to simplify it. That is its coterminal angle. And then we're going to do 13 pi over 6 minus 12 pi over 6. And in class, we realized, that doesn't give us a negative coterminal. That's another coterminal angle, but it's not the negative one. So we'll need to take pi over 6 and subtract another 2 pi, which we're using 12 pi over 6 to be 2 pi. And there we go. There's our other coterminal angle. I'm going to check on the time because I know we're doing the unit circle as well. So if you need to pause and take a break because it's coming up to 20 minutes, I could tell it was, and then just meet me back after you take your break. All right, so now we're looking at negative 3 pi over 4. I'm going to sketch it real quickly. So my initial side is here. Negative 3/4 pi, if I went a negative pi, I would be right back here, right? But it's not negative pi. It is negative 3/4. So I just can go 3/4. So it's going to be right here. And if that's the third quadrant. And now we'll go ahead and do the coterminal angles. So of course I want to add 2 pi, but how am I going to write 2 pi? I'm going to write it as 8 pi over 4. So I want you to be able to be pretty quick with this, so we don't waste our time finding common denominators all the time. We can do it in our head sometimes. All right, so that's our positive coterminal angle, and then our negative one is negative 11 pi over 8. All right. Okay, we did some marker boards in class. Okay, let's talk about supplements and complements. So when we see the word supplement, we know that means 2 angles, one angle plus a second angle, adding up to 180 degrees, okay? And when we're talking about complement, we're saying we take one angle plus a second angle, and they add up to 90 degrees. So let's go ahead and do this. Or, I should have said 90. Why don't we use, instead of degrees, why don't we use radians, right? Because they're giving us radians. So that's pi, and that's pi over 2. Okay, so there's a lot of different ways you could do this problem. You could say they gave me 5 pi over 12. I don't know the second angle, right? The second angle, but I know altogether they equal pi. To find the second angle, I'm going to go ahead and say pi minus 5 pi over 12. Some people can skip that first part and just go, I know they add up to pi, so I'm going to take pi, subtract 5 pi over 12, and I'm going to get my answer. But for those of you that wonder, well, where did pi minus 5 pi over 12 come from? Well, now you know where it came from. All right, I'm going to have to write pi as 12 pi over 12 minus 5 pi over 12, and that gives me 7 pi over 12. So 7 pi over 12 plus 5 pi over 12, yep, that makes sense. That's 12 pi over 12, which is pi. That's its supplement. All right, so let's look at example 7. Once again, we are given a radian, so we're going to have one angle that they gave us, 2 pi over 5. We don't know what the second angle is, but we do know that they add up to pi over 2. Once again, you don't have to do this step. You would just take pi over 2 minus 2 pi over 5. Are we going to have to find common denominators? Yep, we're going to do it for both of them. So what's my common denominator when I have a 2 and a 5? That's right, a 10. So I multiply the denominator by 5 to get 10. I multiply the numerator by 5 to get 5 pi. I multiply the denominator by 2 to get 10. I multiply the numerator by 2 to get 4 pi. 5 pi minus 4 pi is pi. Pi over 10 is the complement. All right, so that was really the end of 4.1, but we're going to start to build the unit circle, and we're going to focus on the angles, and then we're going to continue this next class with 4.2, which is really the unit circle. All right, so we were focusing on angles today, and that's why I wanted to include this part of building the unit circle in today's lesson. So we talked about this angle being 0, right? 0 degrees and 0. We'll put a 0 degree. It's also 0 radians. And we talked about this being 90 degrees. We talked about this being 180. 100 degrees first a second. This is 270. We also talked about the radians, right? This is This is also 0 radians. This is pi over 2 radians. This is pi radians. And this is 3 pi over 2 radians. So we talked about the major spokes in the unit circle. And so for reasons that I'll explain next class, this first angle that's formed using this initial side and this terminal side, that is a 30-degree angle. And so I want you to notice something. We built some what I call bow ties in class because there are other, even though this is the only angle that is actually 30 degrees, there are other angles in this unit circle that are 30 degrees away from the x-axis. Can you guys see that, this is 30 degrees away from the x-axis. This angle right here is 30 degrees away from the x-axis. This angle, now I know I'm not using initial side, okay, so don't worry, I realize I'm doing that, but see how that's 30 degrees, and right here, that's also 30 degrees? All of those spokes are 30 degrees away from the x-axis, and we're going to use that knowledge to label the rest of the ones in what I call the bow tie. So let's see, we're going to make our bow tie with all the spokes that are 30 degrees away from the x-axis. We're going to use that knowledge to fill in the unit circle. All right, it's not perfect, that's okay. So let's see, if I go all the way from this side all the way to here, that's equal to pi, right? Or I'm sorry, I'm doing degrees first. That's 180, but I have to back it up 30, right? Because I'm really just on, I'm not to 180, I had to back it up 30 degrees. So 180 minus 30 is going to give me 150. Okay, so that's 150 degrees. Same thing to find this next angle right here. If I went all the way to 180, I'm not there yet, I have to add another 30. So 180 plus 30 is 210. Let me undo what I did. There we go, 210 degrees. And same thing here for our last angle. If I went all the way around, that'd be 360 degrees. Well, I went too far. I have to back it up 30. So 360 minus 30 is 330 degrees. And we're going to use that same pattern to find all of our angles. We're going to go ahead and stop with this bow tie with the degrees, and let's pick up with the radians. So when we're doing radians, we know we could say 30 degrees, we could multiply what, pi over 180, and we're going to get what, pi over 6? All right, so that's going to be pi over 6. And so we know that all of these angles in the bow tie are pi over 6 away from the x-axis. That means to find this angle right here, I know I go all the way to pi, but I'm going to back it up pi over 6. So pi minus pi over 6 is 5 pi over 6. I surely would like some backup here. I wish you guys could be giving me the answers while I'm writing, but let's make sure. Yep, pi minus pi over 6 is 5 pi over 6. And so same thing with this next angle. I can go all the way to pi. I'm still not there. I've got to add another pi over 6. So pi plus pi over 6 is 7 pi over 6. And then for my last angle, I could go all the way to 2 pi, but I have to back it up pi over 6 to get there. So 2 pi minus pi over 6, let's see, 2 pi minus pi over 6. Well, that's really a 12 pi over 6 minus pi over 6, which gives me 11 pi over 6. Do you notice that all of the angles, the radian measures in the bow tie, they all have the denominator of 6? You're going to find other patterns if you just look at this that are pretty darn cool. But let's move on to our next bow tie. The next spoke up from the 30 is a 45-degree angle. And it looks like a 45-degree angle, doesn't it? So now we're going to focus on a new bow tie. We're going to focus on all the spokes that are 45 degrees. Oh, there's a little bend in that bow tie, away from the x-axis. All right, so here we go. We're going to do the same thing. We're going to be like, oh, all the way to 180. No, not quite. Got to go back up 45. So 180 minus 45. This is when I've been talking for too long. I'm going to have to turn to my calculator because I don't trust my mind right now. 180 minus 45, that's 135. So it's 135 degrees. And then if we could do the same thing that we did before, we go all the way to 180 and realize, nope, we need to go another 45. So 180 plus 45 is going to give me the 225. And then we're going to do the same thing. I wonder if we went all the way around, that'd be 360. We got to back it up 45. So 360 minus 45 is equal to 315. And then we'll do the same thing with radians. So when I look at radians, I know that 45 degrees is the same as pi over 4. So if I could, I'm the same pattern, right? I go all the way to pi, but nope, back it up, pi over 4. So pi minus pi over 4 is going to give me 3 pi over 4, right? All right, same thing for the next one. I go all the way to pi, and then I keep going another pi over 4. So pi plus pi over 4 is 5 pi over 4. And then I could go all the way around to 2 pi, which is 8 pi over 4. But I have to back it up pi over 4. So 8 pi over 4 minus pi over 4 is 7 pi over 4. Might be time consuming to do this, but it sure makes sense when we do it this way, right? I'm hoping. So once again, notice in that bow tie, all of the radians are, they have a 4 in the denominator. All right, so let's look at the next bow tie. I'm running out of color. Oh, I guess I'll use blue. You know, I'm going to use black because I'll use blue. All right, so the next bow tie is this angle is 60 degrees. And so we're going to make a bow tie with all of the angles that are 60 degrees away from the x-axis, because as we have learned, they're all connected. There's a pattern with these bow tie angles. And so we're going to use the same method to get to all the other angles. If I go all the way over to 180, but back it up 60, 180 minus 60 is 120. If I go all the way to 180 and then go another 60, 180 plus 60, yeah, you're going to laugh, but I've been talking too long. I am going to use my calculator for that, 340. And then, oops, I did 180 plus 160. See, that's a little scary there. I need to wrap this video up. 180 plus just plain old 60. Okay, that gives me 240. And if I go all the way around to 360 but back it up 60, I'm at 300 degrees. All right, and now we're going to go ahead. Wow, I really did that, didn't I? I did those numbers in blue instead of green. All right, this is 60. This is 120. This is 240. And this is 300. We want our radians to stay in blue. 100 degrees stay in green. All right, let's do radians. So 60 degrees, that's the same as pi over 3. And so all of the angles in this bow tie are pi over 3 away from the x-axis. So if I go all the way to pi, but back it up pi over 3, pi minus pi over 3 is 2 pi over 3. If I do pi and add another pi over 3, I'm going to get, what, 4 pi over 3? And then I go all the way around to 2 pi, which I think of as 6 pi over 3, and I back it up pi over 3. I've got 5 pi over 3. And I think the only thing we're missing here is to have a 2 pi here as well. Okay, that's a lot, and I think some of the most challenging parts of it for some of you is that we have to deal with fractions. I think some of us have hang-ups on fractions, and it just looks confusing, but if you slow down and you try to make your own unit circle and then come back and check it with mine, I think that will really, really help. I'm hoping that this is the end of our video because, boy, it's been a long one. Yep, I gave you a WebAssign. Thanks for joining me. I will see you in class.